Hello, Algebra 2. Today we have parabolas and inequalities. Very similar stuff to absolute value inequalities, and very similar stuff to how we graphed on day 1. These are all going to be in vertex form. Okay, so these are all going to be in vertex form, which basically gives away the vertex. Then you're going to use your points pattern to get your other dots and your axis of symmetry to reflect them over. And then we have to worry about solid line versus dotted line and shading. Remember from our absolute value inequalities, if it has less than or equal to or greater than or equal to, if it has the or equal to, the extra line on the bottom, you're going to use the extra ink or extra pencil lead. Solid lines. Okay, greater than, less than, dotted lines. If it's greater, y is greater, I should put a y there, shouldn't I? If it's y is greater than or equal to or y is greater than, we're going up. If the y's are less than or equal to or less, we're going down. Just some rough sketch examples here, just to remind you. If we have y is greater than x plus 1 squared minus 2, we're 1 left, 2 down. It's greater than, so we're doing our parabola with dotted line, and greater than's up. Okay, here is less than. This is dotted. Sorry, it kind of got blurred together there. 1 left, 2 down, dotted line, and under. Okay, negative in the front, and we're greater than or equal to. So we have negative, we're going down with our parabola. Greater than or equal to, so solid line, and we're shading up. Again, we have a negative, so we're going down. And we have a solid line for less than or equal to, solid line. And we're going down. So there's your possibilities you could have. Okay, you could have a parabola going up with a dotted line, shaded inside or up. You could have a parabola going up and shaded down. You could have a parabola going down and shading up. You could have a parabola going down and shading down. Let's take a look. We got y is greater than x minus 2 squared. No vertical shifting out here. So minus 2 on the inside is just 2 to the right. Just 2 to the right. Okay, no multiplier. So we're over 1, up 1. Over 2, up 1, 2, 3, 4. Let's make sure we have our axis of symmetry. We're going to reflect these points over. And greater than. So is that a solid line or a dotted line? It doesn't have the extra bar underneath, so this is a dotted line. Or dotted curve, I should say. And greater than means up. So I'm going to put my pen on one of these dots. And which way is greater? Up, 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 up. Just like before, we have to answer all these questions too. Where was our vertex? It was at 2, 0. Axis of symmetry, x equals that x coordinate from the vertex, 2. Y-intercept, most of these again are going to be pretty friendly and cross the y-axis on the graph. This one's going to be 1, 2, 3, 4. 0, 4. In our domain and range, actually we don't probably need that, do we? For the inequality ones, we didn't do domain and range for the absolute value ones either. Okay? Alright, let's have you try this one on your own. Go ahead and push pause and give this one a go. Alright, let's check out how you did. This one should be 2 to the left and 3 down. So we are at -2, -3. No multiplier again, so over 1, up 1, over 2, up 4. We have our axis of symmetry at x equals -2. We're going to use that axis of symmetry to reflect these over. And less than or equal to, so this is a solid line. It has the extra line underneath there, so we have a solid curve. And less than, so I'm going to put my pen on one of the dots. Y's are less. Which way would the Y's be less? Up here or down there? Down. So we're shading down this time. Our vertex was -2, -3. Axis of symmetry should match that x-coordinate of the vertex. Y-intercept was 0, 1. And we said we don't need to do domain and range for inequalities. All right, let's get moving on to the back side. All right. Ooh, we got a negative this time. So we're 1 to the right and 2 up. So that's 1, 2. Negative. Okay, so we're going to do our points pattern, but going down. Over 1, down 1. Over 2, down 1, 2, 3, 4. We're going to reflect those over. And greater than or equal to, so solid. Put your pen or pencil on one of the dots. Greater than. Which way is greater for your Y's? Up. Vertex was 1, 2. Axis of symmetry was 1. Our y-intercept was 0, 1. And we're not doing domain and range today. Okay. I think we're okay here with these. Let's drop on down to fractions. Okay? Fractions. And I'm going to do the bottom right one with you because it's a fraction we haven't done before. A third. Okay? A third. So no sweat here with the first part. 1 to the right, 4 down. 1 right, 1, 2, 3, 4. So we're at 1, -4. But we have a 1/3 multiplier. So that's going to be pretty yucky, right? Over 1, up a third. Over 2, 2 squared is 4, times a third would be 4/3. That'd be 1 and another little bit. Pretty yucky, not nice. So for a third, you're actually going to have to go out 3 to get your nice point. 1, 2, 3. 3 squared is 9. 9 times a third, or divide by 3, brings it back down to 3. So over 3, 1, 2, 3, up 3, 1, 2, 3. Can you guess what the next nice one would be with a third? Not 4 out, not 5 out, 6. 1, 2, 3, 4, 5, 6. 6 squared is 36. But times a third, or divide by 3, is up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we got our axis of symmetry line. And we can reflect this. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we are greater than, so it's a dotted line, dotted curve. And greater than is up. Okay? So, 1/3. We had to go out 3 and out 6 to get nice points. And for this one, it did fit. Okay, I can't promise that they will always fit. If it doesn't fit, you should be able to get 3. You should be able to at least get out 3. And then you might have to do a decimal one, do the best you can, and then write down what the point is. Okay, if you can't get 2 nice points with a third, you're going to go at least get 1 nice set and do another one with a decimal one and write the points down next to it. Okay, our vertex here was 1, -4. Our axis of symmetry is x equals 1. Our y-intercept, ooh, that's yucky. That's over 1, up a third. That's going to be 0, -3. Let's just go fractions, 2/3, or -3.6 repeating. And domain and range we're not doing. Oh, sorry, we're off screen by just a touch. Okay. Now, more familiar to you is the half. We did that on the first day, and that is a little bit friendlier because you only have to go out 2. Actually, out 1 isn't even bad. It's going to be a 0.5 if you want to write that down. And then out 2 should be a nice one, and out 4 should be a nice one. But the odd ones, 1 and 3, aren't even that bad. They're just going to end in 0.5. All right, so let's have you hit pause and try this one on your own. Ready, set, go. All right, welcome back. Let's check it out. We're going to be 2 to the left and 2 up. -2, 2. Okay, before I forget again, we're going to draw that axis of symmetry. X equals -2. And we are going down and then a half. So I'm just going to put those there. I'm not going to use them. We're going to go out 2, 1, 2. 2 squared is normally 4, but we're negative and we're half. So we're going to go down 2. And reflect, 1, 2, 1, 2. Okay, 3 would also give us a decimal one. We're going to have to go out 4, 1, 2, 3, 4. 4 squared is 16. So usually we'd go up 16. But we have a -1/2. So we're going to go down half of it, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and reflect. 1, 2, 3, 4. 1, 2, 3, 4. Less than or equal to, that's going to be solid. Beautiful. Wow. Ended with nearly perfect one. Vertex, we got -2, 2. Axis of symmetry is -2. And our y-intercept was actually 0, 0 that time. No domain and range. All right. Thanks for watching, kids. Good luck on that. Ooh, I didn't shade. Pay attention to the shading, Mr. Handke. Less than or equal to is going down. All right. Good luck on your worksheet, and I will see you next time.